Hi there, how are you doing? Okay, got a few of us. It's that magic night called the Thursday night before spring break, and it's like a tomb. That's okay. That's what we've got this for. And just to kind of run us through some of the logistics of what's going on, and if those who join in a little bit later, we can always go back and see the start. But uh, first of all, I don't have anything in here for you this week that's due for Module 6. And you know we've been working ahead, so we'll talk about that in just a moment. But I do have some resources for you that I think would be useful for you to see. One of them covers these are information builders, some of the trends in data warehousing. This is from a really excellent website called the Code Academy. And you can go there and learn just about, they have SQL, they have Python, just about anything you could imagine. Then here is a link that you'll need later on about how to access SAS Visual Analytics, and I'd like you to do that. And then here's a link to a resource about the sport of baseball, and again another application of databases where folks are trying in that sport to find some metrics that have to do with their fielding skills, just like we have all kinds of metrics for people who hit baseballs. Now, I also have a link, and I think I'd said that I want to show you. And when I talk about databases as being a business model, this is one of the better examples I can show you. This is an article. It's over from the New York Times. And incidentally, I would say this. I think it's good for you to begin a habit of using the New York Times, LA Times, HBR Online, Harvard Business Review, MIT Sloan Management. And I think those publications are going to really give you a sense of what's going on out there in the business world. What are the top minds and top companies thinking about and doing? I especially like the New York Times for a simple reason. I think the business section of the New York Times is the best there is. It has a section called Deal Book that's very, very useful. If you want to see what's going to happen, business is a lot like crime in the sense that if you follow the money, you're gonna start to figure out what's going on very, very quickly. And this is an article about the retailers meeting there in Las Vegas. They have an annual meeting, and the chief CEO of Saks talked about, this is a shop talk conference for retailers, and they talked about their use of recognition technology, facial recognition technology, and trying to make their retail shopping experience to enhance that for the folks who trade with them. And these many retailers use facial recognition today to be on the lookout for folks who are petty thieves, shoplifters, and they'll often scan faces as folks come in and try to match them up with databases. Although many of them will say they don't do it, a lot of them do it. But again, these are retailers who are saying, what do we need to do to survive an onslaught of Amazon, particularly them, and anybody else who's selling online? How do we preserve or try to defend what little bit we've got left in terms of retail experience? And so they talk about the use of facial technology, facial recognition technology. And facial recognition technology is at its core nothing more than a database. That's all it is. So as I say to you many times, the value of this course is you play around with a little bit of code, you learn about databases, you learn about data warehouses, data marts, extracting data from them, the analytic cube, those concepts, which puts you ahead of your peers in terms of understanding the potential of these technologies and how they can become a way to rethink your business model. And I'm going to give you a really good example. It's Turner Classic Movies. as many of you know, I am a freak about old films. I love film noir, is probably my favorite of those types. And when you get tired of seeing computer-generated stuff and a lot of gratuitous violence, go watch some of those movies, because you're going to see some stuff that's really fantastic. What's amazing to me is how artistic those folks are handling black and white photography. That all aside, Turner Classic Movies was founded by a man by the name of Ted Turner, and he had the original called Superstation, TBS. And in its early days, TBS broadcast over, or the UFH or VFH, I can't remember, but the high frequency that was the opposite of the local television affiliates. And if you know anything about TBS, for years, Ted Turner grabbed anything he could broadcast, including the Atlanta Braves when they were really bad. And so you could, any night, if you wanted to, you could see the Braves play somebody, and some nights you could see them play someone who maybe you were a fan of. But to make a long story short, just about the time, this is in the late 80s, that the big studios, the old production studios, MGM, United Artists, on and on, that had been organized around a factory model. These places, that's why they would call the movies the dream factories, because literally what they'd do is they would just produce. They'd get talent, they'd take you on, they'd get you a bio and all this stuff, and they would just churn out movies like a production. In the 1970s, you had a lot of independent companies that started up, and you had this disruptive influence at industries in terms of independent producers. And now the movie industry is really trying to cope with live stream, YouTube, etc. But what Turner did was he saw value, and he purchased all of those old movies for just practically nothing. And then he went to all the stations across the United States and said, if you don't have anything to show at 11 o'clock at night or 12 o'clock at night or 1 in the morning, I've got movies I'll sell you. Or if you want to have something on Saturday night, if you want to opt out of what the network might try to cram down your throat for a Saturday night, I'll sell it to you. I'll sell you the time and sell you the movies. And so that whole business started. And if you go over their virtual business, plus they have ground-based experiences for people who are fans. But it all really started with him understanding that the catalogs had great value. So this technology is a game changer, and the more familiar you are with it, the better off. And I wanted to share that with you and kind of give you that little sermonette. I think it's just a fascinating article, and you can see this in just about everything that's going on out there in the world in terms of social media, all the way from that to computers and chips embedded in devices, cars, appliances, etc., etc., etc. So this is an important class for you, if anything, just to get a little bit of behind the scenes of what happens in a database and how you can use it to not only maybe create that analytical cube we talk about and slice and create the capacity to slice and dice data, etc., but maybe to create a business model. And so that's something that I think that you would want to take a look at. Now, we're going to be working with 14, and like I said, we've been with the Lunches Database 14, we've been working way ahead, okay? So at this point, you should have uploaded everything up to 13. I did the second part of our class was 13, so we're going to start with 14. And I have them down on my desktop, so I'm going to grab the SQL Fun, and I'm going to copy this. And I'm going to paste it. I'm going to call it Chapter 14. I'm going to rename it Chapter 14 because that's what we're going to work with. Now, again, as we work with this, you'll notice I'm using the same file. I'm using the same file, really the same database over and over and over. I'm just changing the queries that I run, and I'm just renaming it. Now, I do this for a reason, to show you that when we create a database, I can't emphasize this enough, the value of it is this: the table is only updated or changed if it's necessary. If we want to extract some information from it, we run a query. And when we run the queries, we talked about before, we create a thing called a view. And once we've created a view, we can run views off of it, etc. ad infinitum. But what gets saved is not, we don't create a new table. We save a picture of a table, a view. So when we pull it up, we get a data set. And so we don't have to rebuild the table or repopulate it. We can just keep moving on with the table and adding to it and connecting tables. And so there's that whole wide thing underneath that's going on as those tables are being related to each other. Now, I'm going to open this up and I'll talk about that for just a moment. And then we're going to start joins, because we're moving in this point where we're starting to look at these joins. And here we're combining tables. So we've really moved the emphasis of the course off of records. Okay, we've moved it off of columns or fields or dimensions and those combinations that make up a record. And we've continued to run some queries and some different types of queries and talked about the graphic user interface and its impact. And now we start to move into the part where we really where we can really leverage what we call the law of large numbers by connecting all of these tables and running queries. Now, over on and you should always have your textbook if you really want to get the most out of this. Over on 14, they talk about outer joins, okay, and that they're derived from inner joins. And I'm going to open up the code for chapter 14, excuse me, and highlight it a little bit in the event you didn't have your textbook. Okay. Now, here's 14.1. I've got it highlighted for you. Well, let's look at it for just a minute. Okay, there's no big surprise here. I've got a select, I use a select, and then I've got a table A dot, meaning in the asterisk, meaning I'm going to get everything from table A, everything from table B, and then I identify table A as the table called twos, and I identify table B as the table called threes. So just like I can use a column alias to add a column to a table or a data set, or I could use a column alias to mask the real name of a table for security or maybe make it more descriptive. I can also use create table aliases or additional or copies of tables, okay, and then relate them. Now, when we think about a relational database, we're really talking about what people call correlated data. And then if you've had your stat, you've done correlation coefficients. But when we talk about correlated data, we're talking about, with databases, we're talking about inside the machine an actual physical address wherever that table is stored that corresponds with another address. They're linked physically. Because they're linked physically, we can run a query and take a picture of what we get. So that's the value, and that's really in truth what's going on. Okay, now we add the where clause, and notice here we do the join, okay, and then we order it by number 2. So let's go ahead and copy that and then run the query. This is 14.1. And so I'll click create and go into the query design. Didn't copy it. helps to copy. My apologies. Okay, let's run it. And here we are. We've got number 2. So we've got 6, 12, 18. And what we have is a list of numbers, word number 2, and then word 2, and then number 3, okay, and then word 3. So we've taken these tables and we've done really an outer join of the two of them based on the inner join. So this 14.1, okay, well, pardon me, this is the inner join. And if you take a look over on page 520, they're going to show you the beginning tables, all right? And then they show you the result table, okay, which we've got. And then when we run that next table, we're going to drop the rows and so forth, and we'll end up with that result table. And you can see that over there at the bottom, page 521. But the authors walk you through that parsing of those tables as it links itself up, okay? Now, they give you some information there about page on 521, the top of 521, the 3 types of joins, the left outer join, the right outer join, and the full outer join. What are they? How do they work? And they all have some different they all have some different purposes. It just depends on what table you want to extract data from, okay? And what data in the other table or tables will be excluded. And so you're just simply parsing through those. And of course, before he talks about 3. Now over on page 522, okay, he shows us a left outer join. Now before we run the code and look at it, let's look at the tables, okay? Sometimes looking at the data set helps. And if I'm on page 523, if you take a look there, you've got the beginning tables, you have the 2's table and the 3's table, okay? Now the authors are making this very simplistic, a few cases, simple kinds of data to work with. And so they understand this as a model, and this textbook's really designed for decision makers, really not so much for people who are, let me put it like this, if you're a computer scientist, you're probably more doing database programming, fitting a database into a website, an e-commerce store, whatever, so you can do online analytical processing. On our side of things, we're more interested in the decision parts, and so we've got to be interested in where the data comes that we get the decision. So they've got, and notice what we have. We have these beginning tables, okay? We have a null value here at the end of this table, and both tables have a null value. And then here's the result table. Now we have a left outer join, okay? And what that means is we have everything from that 2's table, and then we have anything in the 3's table that matches. You say, okay, give me a practical example. Okay, let's say that I have my left table, or the parent table, is say I'm gonna send out a mailing, and I want to send it to all of the Republican voters in Oklahoma County. Okay, that's my parent table, right? And then I want to send, and I could even qualify by a certain zip code. Let's say with a certain zip code, age, mean a certain characteristic. And then the right hand, the child table, I'm going to pull that same group out of Tulsa. But then I decide I'm just going to look at everybody in Oklahoma County. So I do that, and then I see where they match. Those in Oklahoma County that fit the characteristics that match up with those in Tulsa, and then I have everybody in Oklahoma County, and I have some way to put my 2 sets, my result set, into some kind of perspective. and we're going to see this as a right outer join works the same way. Okay, I wanted everything, all the records in Oklahoma County, and I also wanted the ones in Tulsa that matched with a certain set of criteria. Okay? And that way I can put it all into perspective. If I wanted to, I could run a join of both Oklahoma County and Tulsa County and say I just want all the Republicans. Okay, and then I can winnow things down from there. It was really interesting. I got a letter this week. It came from Washington, D.C. It was a mailer, and it addressed me and told me about all the terrible things are about to happen in the country if I didn't send them money to the Republican National Committee. Frankly, I don't know why they bother me. I'm not rich enough to be giving them money anyway. I'm not even rich, but I'm not even a Republican. I'm registered independent. So it was interesting when I looked at it and I thought somebody, as they pulled this together, missed the mark because their mailer just went right in my mail. So they wasted the franking privilege or whatever they had there that they paid for. So this is going to be, we're going to call this 14.1, and then we're going to run 14.3. And that's, again, we're strategizing in terms of what we want from the data. And that really is, I mean, that's really the heart of this is, what is it that I need to exclude? What do I need to keep? And what do I need to correlate? Now here's 14.3, and we'll go ahead and click create, and we'll do another query. Okay. And we run it. And here's our results set. And we'll call this, it was 14.1 should be the one before that. Let's say that's 14.1. I don't know why I saved that. Yeah, that's right. Let's call this, just keep it easier on ourselves. We'll call this 14-3-2. Okay. We can always go back and rename these ones we got on park, but once they're when they're open and active, we don't want to mess with them. Now, if you notice at the bottom of page 523, you're going to see the results set. Okay. Now the authors showed us we've got the number 2, the word 2, the number 3, and the word 3. Now notice, all right, we're doing a left outer join. I'll go down and take a look at the SQL. This says to the machine, grab the parent table. The parent table is the left. The child is the right. That's just a naming convention that that people use to separate the two tables. Now, if you have, when you start stringing bunches and bunches of tables together, you have to figure out, okay, which one is going to be my parent table and what will be all of the child tables that are out there. And that can be a little bit tricky, but as you're trying to look at those relationships. But you'll notice there, as we've winnowed that down, okay, we have about as many records in the left outer join. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 records, okay? So I got all the records, okay? But then I also got additional records from the number 3 and the word 3. So I got more dimensions within each record than I had prior to when we had the 2's table and the 3 table, and we had not run the left outer join. 14.4 is a right outer join. So let's look at the code for it. And this time this time the table of interest is the child table, or the one on the right. You say this sounds suspiciously like Venn diagrams, and you're right. That's exactly what we're playing around with here for all intents and purposes. And we'll do the query design. We're going to close it off. Okay. And I'll run it. And here's our result set. Now you'll see page 525, and this is 14.4. Let's look at that for just a moment. What we've got. Ah, 14.4. Thank you. Now, in this case, the author shows some older syntax, but we're doing a right outer join here. So we're after everything from the child, and that's the threes table, and then whatever matches with the twos table. Now, as I mentioned before, I do some strategizing with this. I may strategize I may use a right outer join because I have more records in the child table than I do in the parent table. I may have more records in the parent table than I do the child, so I'll do a left outer join. Many, many times I strategize on the basis of which table has the greatest amount of data, okay? And how do I line them up as a parent or a child table? The idea often here is to get as many records as we can get. Early on when we were running queries, we were extracting data and we were parsing it to the extent we get the bare bones response. Here I want everything on the right and whatever matches on the left, okay? And this might be, I want all of the, let's say I'm Pep Boys, and I go into the database and I find all of the parts for a drum system, brake for a 1965 Malibu. They were making them 65, I think they were. And then I want all of the parts that match from a 1971 Chevy Impala. Why? Well, I found out because I'm Pep Boys and I'm a parts freak that I know that there are components from the 71 model that fit with the 65. The 65, and so we've retained part of the 65 brake components. I'm just making up an example here, but I think you can see what we're talking about in terms of why we would strategize or the strategies behind these joins. So that's 14.4. Then we come and we see a critter called a full outer join. Okay, and a full outer join, and they talk about there at the bottom, page 526, and at the top of 527. Okay, a full outer join means I take everything from A and I take everything from B, the whole kit and caboodle, even if I have duplicate records. If I run a union, I get rid of duplicate records. I keep where they match, but I don't keep duplicates. It may be useful for me to run a outer join if I want to see all of the purchases during a given hour in a particular store where I want to see I want to have duplicates. I may want to see, I may run a full outer join on a set of accounting, like a payroll, to see if I've got duplicate payroll, if I've got duplicate checks being issued. And if I do, then I begin to ask the question, why, oh why, am I sending 4 checks this week to the same person at the same address? Or why is my purchasing department cutting a check for 4 invoices for the same company, same items? One of the ways people try to steal money, they'll create ghost payroll, or a lot of times you'll hear it on the news. So and so out here in so and so school district got caught stealing $2 million, And probably what they were doing is they were issuing using that whole complex PO and invoice and PR system, and they were just duplicating things and then cutting checks in duplicate and sending them out. And nobody was really for the wiser until the auditors came in and started doing some of these full outer joins and going, wait a minute, this doesn't look right. We're getting some duplicates here when we shouldn't. Or if we want to test for duplicates. Now at the bottom of page 527, he shows us some code. Now this is 14.5, but if I'm not mistaken, this is not what's in the, it's not in the book. Let me take a look, make sure for that though. We've got joy, today, because I thought I recall, I may be mistaken there, and then it's got the from twos, left outer join, 3B, and no, because I don't have the union. Okay, no, I don't, because I don't have the full, because I don't have the union. If you've got the textbook there, you could see it. Follow what we're doing here. Okay, we're going to select everything out of A, everything out of B. From twos is the A table, and threes is the B table. And I'm going to do a left outer join. So I want everything out of the parent table, the left table, and then whatever matches in the child table. Okay. Then notice here, since I've done I've done the left outer join, and then I do a union. A union means I'm going to all of the records, and I'm going to get out, and I'm going to get rid of any duplicates. Then as we come down there, and this is on page 527, now I'm going to do a right outer join. Okay. Now he has Oracle textbook. He has Oracle over here. His 4.5 is Oracle code, but the access code is there at the bottom of page 527. So watch the strategy that happens. I do a left outer join that says I get everything in the parent table and only that which matches in the child table. Okay. Then I do a union, which means I get everything. And then I parse it again by taking everything from the child table, i.e. a right outer join. And so as you look over at page 527, page 528, you see the beginning tables, which were the twos tables and three tables, and then you see the result table for the full outer join. Okay, and we've had the union out there as well. So we've done that full outer join in the union, then we preserved all the duplicate records. The strategy at the bottom of page 527 is pretty simple. I know I want everything from table A, or the parent. I want everything from table B, the child, and then I want to find where they match. And then I use the union, and I duplicate the records, and I'm okay duplicating the records because I've already parsed them. But I just pull it back in and reduplicate them. But I parse the data through that, and as you think about it, I'm taking from here and matching here. I'm taking from here and matching here, and then I grab everything. Because I've already done those the left outer join, the right outer join, and the union means I take pardon me. The union eliminates the duplicate rows. I'm sorry, it's union all that takes everything. Union eliminates the duplicates. My apologies. My brain went numb on me for a minute. Which kind of gives us a nice segue over to page 521, which talks about the union. Okay. And page 530 has a nice I wish I could get the people at VitalSource to put this textbook, or I bought it just buy this silly thing and put it on Kindle. I mean, it's absurd. I'm buying 6 different devices to look at a book. But nonetheless, on page 530, I've got table A, table B, okay? And then those 2 separate tables are pulled into an AB. And then I end up with a CAB with a union. And I get rid of the duplicate rows. Okay, so I've just winnowed it down. I apologize about the union. It's union all that keeps everybody. It's union that removes the duplicates. My apologies. Down at the bottom of page 530, the authors show you the statement for that pending diagram. Select from A, union. Select everything from B. And you pull all of that together. Now they also show you there over on 531 a series of steps to go through to form a union. Okay. And 14.7, let's look at it for just a second. Okay, this is a section. Okay, 14.7.6. Okay, let's look at this for just a minute. Now, let me stop for a moment and say this. The chances are you won't run the code. The chances are you might have a client application that lets you pull in data sets, okay, and maybe perform some operations. But if you're working for a sizable organization, you're far better off literally to sit down with a piece of paper and a pencil and say, okay, what's the parent table or parent dimensions that I want? Because you may not know what tables they're in. So right, I say I want the customer ID, blah, blah, blah. Then your child table, and then begin to list a series of queries, and that will give the folks in IT, if you're going to go back and give them a specialized query to run. This is in a large company that has a lot of customers. If you encounter this kind of thing, and they'll do the code for you and pull it out. But the key thing for you to understand is that you've got to know what's in the child and in the parent and the child tables. Now, again, as you've heard me mention, right, one of the reasons we talk about the data warehouse, we talk about right and left joins, etc., is so that when you go to work somewhere and you open up your computer, you're going to, and up pops your dashboard on your tablet, maybe your laptop, hey, maybe even on the phone. In your brain, you automatically see the tables that appear to be dimension tables, okay, attribute tables, characteristics. You'll also see the tables that look like they're just simply data, okay? And now you're ready to start to parse it. It's not too far akin, excuse me, from pivot table. Now, for my money, unless you're operating with something like, say, SAS Visual Analytics or an Oracle application for a given company, for a given industry, pivot tables can handle some pretty heavy. They can do some pretty heavy lifting, and they can take database information stored in database, especially numeric data that you've got, numeric values, and really whipsaw them and let you see what it all looks like. The authors are trying to kind of simplify things here for you. So let's just go ahead and run this. Okay. And you could, and the text will have the beginning tables and the ending tables. Okay, and you can see the result table. This is also something that will will refresh your memory about what I call query discipline. What do I mean by that? What I mean is, if you're going to go to the trouble of having a dashboard and a data warehouse and data, if you're going to have all of that, okay, where I can go in and procure, you should have in the dashboard your KPIs, key performance indicators that fit your level of in the company and fit your company and its environment, but primarily your company. That's why they're called key performance indicators. Now, when you dial into Canvas next time, take a look. You'll probably see a calendar. You'll probably see work that's due or upcoming assignments. You'll have a grade book. You'll have a number of things that are giving you a dashboard effect. Your grade book is probably the one that's the most. Your grade book certainly. Yeah, I'd say your grade book and probably the calendar and work due. Those are going to be components. To be honest with you, I don't go into the student view that much, although I probably should. And I probably should just sit back, do more looking in the student view and see what it looks like coming in. Although I don't get a true student view because I've had some students in the past show me exactly what they see as they go through. And it doesn't look like what Canvas shows me on student view. So it kind of unnerves me a little bit because I go, wait a minute, I'm supposed to be seeing what you're seeing and I can't. However, in terms of key performance indicators, can see yours. And I'll show you real quickly. I'll show you what I'm talking about since I'm off on this tangent. Open up this real quickly. I have a section over here in Canvas. I'm going to show it very quickly. It's called People. Okay? And it's going to have descriptive data out about everybody. And then if I want to, I'm going to go down to, I had a student in here. But here's everybody. Here I am. And I'm going to look at the user details for me. Okay. This is my dashboard. Messages, instruction, interactions report, an access report, my profile, etc. Any linked stuff. And then I would go into my grade book and take a look at that. So it has a dashboard component to it. Let's see here. And this will be 14.7 that we've run. So I'm ready at 14.8. Okay, 18.4, and that's over on page 1480, excuse me. It's over on page 534. I want to show you this. And you go ahead and run it. We'll talk about it first real quickly. Okay. Notice what's going on. I'm using table aliases, A and B. I use a count function. I use a column alias. And I do a left outer join, and then I do groupings, and then I order them. Now, I identify employees as table A and lunches as table B. And I do the left outer join, so lunches is the parent, okay, on the employee B dot employee, and the employee, the table B, that's my child, and I'm linking them up on the basis of employee ID in table A and table B. In this point, at this juncture, the left outer join, that means that the lunches table is the parent, the other is the child. And so I'm going to get everything from the parent and then whatever matches from the child. It's just a question of what you're after, the information you're after, and that's the reason why. The reason that people like Oracle will not sell you their product unless you sign a thing that says, we'll use your product as you instruct us, we'll go to your training programs and all that, because Oracle wants their product to work for you. And for it to work, it's more than just doing the coding or running the queries. For it to work, you also have to create dimensions that fit with what they see as far as retail operating or any one of the other industries, etc. They build that for you to run it, and it's unnerving to me if I get a client who will say, well, you know, I've modified it a little bit. Okay, to me that makes about as much sense as going out. Let's say you go out and you buy yourself a Ferrari, and you decide, well, you know what I think I'll do is I'm going to hoist it on the lift and I'm going to tinker with the brakes. Unless you're a Ferrari service technician, you're playing with your life. You're going to wrap yourself around something, because a Ferrari is a beast. It's an incredible piece of machinery. And if you don't know what you're doing, you'll kill yourself and somebody else faster than you can whistle Dixie. See, and you can do this to yourself in business if you go in and you don't have query discipline. If you don't have a program you've bought that shows you how to get the types of results that everybody in your industry does that you want, if you just start running queries, you're going to get junk. You might get some stuff that's, if you go fishing with huge sets of data, you might get some insights. But you know, understand you're operating a query that's just, it's like you're fishing. It's called serendipitous querying, meaning you hope you get an insight. You're running the thing, you just hope for the best. Okay. Now, if you have a large enough data set, you can play that game, and sometimes you win. Law enforcement people, cybersecurity people, cyber warfare people play that game. They have access to and collect incredible amounts of data, and so they just kind of throw a blanket out there, or throw a net to see what they catch. They'll throw a net in the sea and drag it in. What do we got? Oh, well, here's a bunch of stuff we don't want. Oh, we found something. That's a very common tactic of theirs, because it saves them a lot of time and energy of really trying to bore down and drill down and get specific data. They'll just throw a drag net out there and see what comes in the door. And this is similar to the policing in many countries, where if a crime is committed, anybody who could possibly be a suspect is just simply rounded up and brought into the station house. And then if you get that one person who looks a little bit more nervous than everybody else, that's the person you start to try to extract information from, or a confession. So we've got this 14.8, and let's go ahead and copy it. These are all just strategizing. And we'll click create, and we'll do the query design. And we'll run it. And this is going to be 14.8. Okay. Let's see the data sheet view. There we are. Now, I realize I've said this over and over about this strategizing, but to make my point and to bring it, click on Database Tools and click on Relationships. That, my friends, is a tangled mess. Now, you could sit there and thank goodness you have a graphic user interface that will let you play and move those around until you see the data flow. Okay? There's some other tools that you can use if you care to. And we'll close this one. The other database tools are a database documenter that'll print out a report for you. Here's a performance analyzer. Here is an analyzer table. Here's object dependence. Okay? And what this will do, and I think it's going to close everybody off and then run it. It's going to take a minute to do it. But the data dependencies, it will show you every object and what it depends on and what depends on it. That helps you see the data flow. As you can see, it's not responding because it's going nutty because I asked him to do this crazy thing. Well, it might do it for us. I doubt it, frankly, but it might. We may be on too slow of a connection. Yeah, where our problem was is to just simply, let's go back over here to the home, and we'll click that off. Now we'll close it. It's going to take us a while, but if I want to, well, it takes me a while to get all of that out to see all the object dependencies. I could go into the relationships and pull those out. That's where you're trying to kind of really figure out the flow of data that you're after. So this is as much about strategizing as it is in terms of just running queries. Over on page 437 is a text file. Oh, they show you some code, but it's not in the text files. That's the Oracle SQL. And that's where they talk about, they have the create the table. Now, at the top of page 537, they show you, and what they do is, okay, it's select A dot everything, B dot lunch ID, B dot lunch date, B dot employee ID as employees ID 2, the date entered, and then they use the N2, okay? So we're selecting those data into that 1409 table, and we're getting the data from the employees. And then we do a left outer join, and that gives us everything in that result table that's shown there in 537. That's why you have your book here, because I don't want to take 10 minutes to sit there and type the code up and run it, all that, when you can see the code quickly and you can see the beginning table. And you'll see you've got A and B, A, then the B, then B. You could see those in that result table. You can see the table from which they came. And that's this 14.9. And they give you a second example of 14.9, but you don't use you use a count, but you don't use the N2. Okay. Now, in another one of these things over on page on 1410. Page 540. What he's got in the text file does not match what's in the text, what's in the book. So what we need to do is a little bit of adjusting. So 14 says looks like the A, B, N, Z. So instead of the NVL, the NV1, I want NZ. So that means no nulls. So A, B, no, okay. Times NZ. A number 2. B number _3. times 1. We're going to do an operator here as the sort order, and we're not going to have any null data. And then of that, we're getting it from Tuesday. Then we're going to do the, and this is what's in the textbook. They want a left outer join instead of a full outer join. And so I'm going to type this in here for a minute. So we want a left outer join on 3's D. There's one. Okay. Now I think, yeah. On left outer join on the 3's B, and that's on the number 2 equals the number 3, and then I have, all right, and then after that number 3, I have a union statement. I have to check this, and then I go through the selects, and then go a whole select statement there. You can write the rest of it out and run the query. What's going on here, and I'm going to walk through the book. We're getting everything out of table A and B. We're going to take the number in 2 and the number in 3 times 1, okay? And I'm going to call it, we're going to call it the sort order. Now we use the NZ, meaning no nulls, and we're going to get that from the 2's A table. At the bottom page 540, they've got the 3's table and the 2's table. So far, so good. Now I'm going to do a left outer join on the 3, so I'm going to get everything in the 3's table and whatever matches in the 2's. And I'm going to use that number 2 equals number 3, those that match up. Then I'm going to do a union, okay? And then I'm going to do another select statement with no nulls. And then I'm going to do the 2's C, and I'm going to do a right outer join and order by a sort order. The textbook there, as you walk through that and run it, and it gives you the result table up here where I've got the number 2, the word 2, the number 3, the word 3, and then a sort order for them. That's all that we got going on. All right. I don't know if it's worth it to do this stuff in patterns. We're back up there, walk up on that one again. Let's see if they've got 1412 as a complete one here, so we can compare 2 tables. And second column. Let's try that, because this will compare a couple of tables. All right. We don't have to mess around with writing a bunch of code. Okay. I'm going to run it. Oh, I should put select. Now let's see if this will play nice. There we go. And there's the results set at the very bottom of page 545. And this is 1412, we'll call that. What we did there is we compared 2 tables to see the extent to which they match. And the result set is what matches. You say, now why would I do that? Well, one of the more useful pieces of this would be if I want to compare payroll tables, I might just want to come in and audit, and I might want to compare payroll tables that were generated, let's say, by HR or by payroll, and the payment tables that were generated by maybe a vendor or the bursar or controller. I want to see how well they match up. Okay, if I've got some matches there, it's one of these things I can just do some checking on it. I'm comparing the two tables. Okay, and we find and they ask us to find the rows in the 1412A table, 2A table, 12.2A table that don't exist in B. Okay, so I'm looking for a discrepancy here. What's in 12A? Okay, that's not in 12B. And if I find that 12A differs from 12B, I might do this. I might go back and take a look at payrolls and then disbursements. Well, that's as good an example as I could give you, because I'm comparing. If you do payroll correctly, you've got somebody who does the workup of the payroll. How much do we pay the person? How much you take for taxes, etc. And then you've got a different department or person who writes the checks. And if you're in an institution like this, then you have a person who signs the checks. Now, I've served as treasurer for a couple of organizations. So let me tell you what, every time I signed a check, it gave me the willies. Because I thought, man, I'm writing a bank draft. I hope this is good. And so I would often upset people by asking them for backup. And I would ask them to supply me with documentation over a certain amount of money or documentation period. So that's kind of a useful part of that, of doing some of the outer joins. Page 547 walks you through comparing two different kinds of joins. He has you do a full outer join, a second outer join, and the result sets. And I think we've talked about the difference between them. Same story there on page 548. And there in 548 and 549, they're giving us counts for the first full outer join, and then the second full outer join. What did we end up with? Differences in terms of records. I'll be honest with you, the rest of 14, I'm looking here to see what I think might really be salient for you. Of course, the key points part at the back end of the chapter is always good. If you look at the bottom of page 550, the authors use some telegraphs there where they show us an Access SQL where we create A times B, okay? And then the very bottom, we create A times B, and that product times C. Because we're using these joins, we're getting a multiplicative effect in terms of the records. And we want to do that. So if we have data that have patterns, we're going to find them. And then at the top of page 551, they show you a B times C. And then notice you're using some set theory here. Then I have A times the product of BC. And then I have there on page 551 at the very bottom, I compare the product of I get A and B times C with A times the product of B and C. As you can ascertain, I'm bouncing the data off of each other using these joins and these tables, and I'm not only harvesting them, I'm creating brand new result sets as I do so. And that really, when you're using outer joins, that really is the name of the game to leverage them. And again, some of it will be determined by the dimensions that are in there. Some will be determined by the amount of data that you're carrying in one of those two tables, either the parent or the child. And there's the result set on page 552. And they show you the multiple of 2, the multiple of 3, the multiple of 5, and then the sources. I don't see any need to run you through it when you've got the textbook and you could see what they were doing back there. And you just have to kind of follow along with it. But at the end, you're using these tables in a to get a multiplicative effect. That is to get sets of iterations as opposed to just an iteration. Really, you're getting permutations is what you're after. And if you have a large enough data set, some things will start to pop out. One of the reasons, and I shared this, I've probably shared this with you guys too, and we're getting into the 7 o'clock hour and you're anxious to go, and so am I. But one of the reasons I think that we do such a great service here is that we expose you to this technology and what you can do with it. Now, as I've said before, to get a sense of how relevant our curriculum is, I trust the authors of our textbooks, because I really try to get the gold standard textbook in every one of these. But I also trust what's going on out in the real world. And so one of my real world litmus tests is I'll go out and I go to like monster.com, that job board, and I'll look, for example, what are the entry-level skills required for somebody to go work for a marketing firm? And what I'm seeing more and more is they want you to have some background in digital advertising, search engine optimization, social media. And if you don't have those, a lot of firms, they're just going to work with you. Some of them want you to be able to use R programming. Some of them will even say, I'd like you to do Python. I look for the entry level for a lot of financial analyst positions. And I was just shocked. These are entry level. I was shocked at how much things have changed, because not only do they want you to have a finance degree, okay, and they would prefer you have finance and accounting, they want you to be able to write Python, and they want you to be able to use R and be able to work with big data. My head starts exploding, okay, as yours is. And I'm saying, wait a minute, you want our students to come out here to work in finance to write Python? Yes, because it's the language of apps. And folks are going to want you to write or understand or be able to put together an application because of so much mobile computing that's going on. You guys, when you're my age, your grandkids will laugh at you that you ever went to a physical bank and used an ATM. They'll just, who does that? It's about as rare as has anybody seen a phone booth lately? Find me one. Well, why? Well, everybody's got a cell phone. If there had been cell phones when if there had been a cell phone when I was your age, my parents probably would have imprisoned me or may have murdered me by the time I was 16 or 17. Because in those days, there's no cell phone. There's no, I can call you anywhere. I can track you or whatever. None of that. I called from a payphone, or I'd be at a friend's house and call from the phone. So all the mobile computing that's happening is really changing the financial services industry. Folks like PayPal, Rocket Mortgage, all of these are moving everything into an app-oriented environment. And I would say this, at some point, any of our students, take a coding class. There's stuff over there like at the Code Academy. We offer courses. The folks down at the community colleges offer those classes, relatively inexpensive, and it just strengthens your resume. But it also helps you get ready for that world that's coming, where everybody wants everything done tomorrow, and they want complete. They want everything done tomorrow, and they want to be able to use their phone to bank, to shop, all this stuff. And that requires you being able to understand how an app's put together and the underlying code and understanding code like Python and the ability to go out and scrape data. A financial analyst, for example, has got to be able to go do more than just go out and look at the IRS statements for if you're looking at a publicly traded firm. You can look at the quarterlies, you can look at the 10Ks, all the annuals, all that stuff, but you're also going to start scraping data from comments about products, reviews, etc. And you got to be able to take that and all of that and put it into a tabular format that we're so used to dealing with. Or you master using some applications like NoSQL that will handle those data, will handle those operations for you, even though they're not structured. They're still unstructured data. Okay, that's chapter 14, and we've talked about it. And hopefully, as you go back, if you really say, Dr. Harmon, you have really thrown a lot for me to chew on. Let me say this. Go back and look at 553, okay? Start with that table, the types of outer joins, the effects on the first table, the effects on the second table. Then walk through those key points, and you'll have the insights that you need to understand how we strategize using left and outer joins. Now, this is 14, so you'll want to upload it, okay, as your workshop credit for 14. Lunches database 14, so you've done that. Lunches database 15 we'll start on when we come back. No, this weekend I'll do the part 2, and I'll look at 15, chapter 15, which deals with union and union all. And that's where we're really working now and starting to really leverage the law of large numbers. Okay? Good. Okay, folks, thank you so much. I appreciate those of you who are online. The 2 of you here, thank you so very much. I know it would be a lot easier to be gone and not be here, and I do appreciate you being here. That'll pretty much do it. So travel safe, come back, and we will see you next week.